There can be many extrema on a function, many maxima and many minima. We call these local extrema because, considering what's going on around them, they are the highest or lowest point. But how do we find the most extreme of the extreme? The highest maximum or the lowest minimum? These are called absolute extrema or global extrema. And to find them, we begin with the candidates test. This simply means we're looking for any point that is a potential maximum or minimum, or a candidate point. This includes all critical points and endpoints if we're dealing with an interval. Once we find the candidate points, we need to find the function values for those points. This will tell us the absolute extrema if they exist. Check out this example. Here, we're given the derivative along with some function values in a table. From the derivative, we can find the critical points. That's where the derivative equals 0 or is undefined. The derivative equals 0 when x equals 0, 1, and negative 2. To find whether these are maxima or minima, we can take a look at the intervals. To test for values less than negative 2, we can use a random number in that interval, like negative 3. If we plug in negative 3 into the derivative, we get a negative times a negative times a negative, which is a negative number. So the derivative is negative, and that means the function is decreasing. From the interval from negative 2 to 0, we can use a number like negative 1. If we plug this in, we get a negative times a negative times a positive. The derivative is positive, the function is increasing. From 0 to 1, we can use a number like 1/2. If we plug this in, we see the derivative is a positive number times a negative number times a positive. Thus, we know the derivative is a negative number, which means the function is decreasing. And finally, what happens for values larger than 1? Well, using a number like 2 for that interval, the derivative is a positive number times a positive number times a positive. So that means the derivative is positive, which means the function is increasing. Whenever the derivative goes from negative to positive, we have a minimum point. This occurs at negative 2 and 1. Whenever the derivative goes from positive to negative, we have a maximum point. This occurs at 0. So we have our local extrema. Now, what if I asked you, what is the smallest value, or the absolute minimum on this function? You may have noticed the table sitting on the right for a while. We found two minimum points, negative 2 and 1. To find the smallest minimum, we just need to check the function values for those minimum points. From the table, we see that negative 2 is smaller than 1. So negative 2 is the absolute minimum point on this function. Don't believe me? Let's check out the graph. Now, what if I asked you to find the largest value or the absolute maximum on this function? Well, looking at the graph, you can see that things get a little tricky. From the candidates test, we found one maximum point at 0. But notice that for values less than negative 2, the function is always decreasing. Similarly, for values after 1, the function is always increasing. As you can see on the graph, this implies that the function increases without bound. The sky is the limit. In other words, we can clearly see that there are values on the function greater than where x equals 0. So 0 is a local maximum or a relative maximum, as it is the largest point with respect to its surroundings, but it is not an absolute maximum, as there are values on this function that are clearly larger than it. If we were dealing with an interval, the process would be very similar. Let's check out this function. What is the absolute maximum point on this function over the interval from negative 3 to 5? Well, let's do the candidates test. What are our critical points? Factoring the derivative function, we get x minus 3 times x plus 2. So when does the derivative equal 0? When x equals 3 or negative 2. Now notice, we are dealing with an interval, meaning our endpoints are also candidate points. Okay, we have our candidate points. Now, which ones are maximum and minimum points? Well, checking the interval from negative 3 to negative 2, we find the derivative is positive. Now, taking a look from negative 2 to 3, the derivative is negative. And from 3 to 5, the derivative is positive. Now, looking at the candidate points, which of these are maximum points? Right after negative 3, the derivative is positive. So the function must be increasing. Thus, negative 3 is a local minimum, not what we're looking for. Taking a look at negative 2, we see that before the function is increasing and after it is decreasing. Perfect, that's a maximum point. So negative 2 is a maximum. What about 3? 3 is a minimum because the function goes from decreasing to increasing. So that's not a maximum point. And what about 5? 5 is an endpoint, and it's also a relative maximum because the function is increasing leading up to it. So we have 2 maximum points, -2 and 5. Which one is the absolute maximum, or which one has the greater function value? Well, looking at the graph, it looks like -2, but let's substitute into the function to make sure. What is f of -2? Well, -2 cubed is -8. -2 squared is 4, 4 over 2 is 2, and -2 times -6 is positive 12. -2 plus 12 plus 1 is 11, and 11 is the same as 33 over 3, so if we add that to -8 over 3, we get 25 over 3. Okay, that's f of -2. What about f of 5? 5 to the power of 3 is 125, 5 squared is 25, and 5 times -6 is -30. -30 plus 1 is -29. Let's get a common denominator of 6. 125 over 3 times 2 over 2 is 250 over 6. -25 over 2 times 3 over 3 is -75 over 6. And -29 times 6 over 6 is -174 over 6. 250 minus 75 is 175, and 175 minus 174 is 1. So f of 5 is 1 over 6. So which one is bigger, f of -2 or f of 5? 25 over 3 is clearly larger than 1 over 6, so -2 is the absolute maximum on this interval. To find the absolute minimum, we can go through the same exact process. We know that on this interval, the function hits a minimum at -3 and 3. Whichever one has the smaller function value is the absolute minimum. So what is f of -3? -3 cubed is -27, over 3 is -9, -3 squared is 9, -6 times -3 is 18. Adding the integers, we get -9 plus 18 plus 1, which is 10. 10 times 2 over 2 is 20 over 2, and then minus 9 over 2 is 11 over 2. So f of -3 is 11 over 2. Now for 3. 3 cubed over 3 is 27 over 3, which is 9. 3 squared is 9. -6 times 3 is -18. -18 plus 9 plus 1 is -8. And then getting the common denominator, we can multiply that by 2 over 2, which is -16 over 2, minus 9 over 2 is -25 over 2. So clearly, f of 3 is smaller, so 3 is the absolute minimum on this function. And that's really how you go about finding the absolute extrema, or the largest and smallest values on a function. Once you use the candidates test and find extrema, all you have to do is check out the function values at those points and compare. Before you head out, the Dino 101 Math merch store is officially live. If you want to support the channel and get some clean math-themed designs, check it out. The link's in the description, along with the bonus discount you can get. Thank you so much for watching. Keep working hard and keep learning. And subscribe.